Fluorescence spectroscopy is a powerful analytical technique for the quantification of fluorescent molecules. But what's behind any fluorescent event? Imagine the rectangle as your sample and arrows as light. When you are irradiating your sample with light that matches its excitation wavelength, you are providing the right amount of energy to put your molecules into an excited state. Being a non-equilibrium state, the molecules quickly relax to ground state, releasing energy under the form of light that matches the emission wavelength. This mechanism is continuously repeated. It is actually an event that occurs in nanoseconds, and to all fluorescent molecules in your sample, so if you keep the irradiation, fluorescence will be continuous. Measuring fluorescent emission, you'll obtain a spectrum like this, with intensity in the y-axis and wavelength in nanometers in the x-axis, and where the maximum corresponds to the emission wavelength. Spectral information can be used as a qualitative tool. Different compounds will have different emission spectra and different excitation wavelengths. It's also a sensitive quantitative technique, as higher concentrations will result in higher intensities in your spectra, and that relation is linear. So, if you measure the emission intensity against an existing calibration, you can easily know its concentration. And believe me, with the right setup and sample, we can really get to low concentrations. This is a typical setup for fluorescence measurements. Here we have a light source for sample excitation, a spectrometer to measure the fluorescence emission, fiber optics to carry light between components, and finally, the sample holder, in this case for liquid cuvettes. You can also measure fluorescence in a flow analysis with a flow cell, or even in solid samples. We have multiple excitation light sources, including xenon lamps or the affordable, high flexibility and high performance LED light source. For emission detection, flex spectrometers allow you to get great sensitivity, but with a Peltier-cooled CCD, ultimate sensitivity is achieved with Sense Spectrometer series. Check our application notes section to understand the performance of our setups and the software information to realize that fluorescence emission spectra can be obtained at light speed. Cheers!